All right, so here we have question number 8, October, November 2021, paper 3, variant 2. The topic is trigonometric identities and integration. This question is worth 7 marks. So by first expanding cos square theta plus sine square theta, the whole thing square, show that cos raised to the power 4 theta plus sine raised to the power 4 theta is exactly equals to 1 minus half times sine square 2 theta. Okay, so first of all, we are going to start with cos square theta plus sine square theta, the whole thing is square. Cos square theta plus sine square theta, the whole thing square, is equals to a square plus 2ab plus b square. We will use the expansion. So cos square theta whole squared plus 2 times cos square theta times sine square theta, and then sine square theta, the whole thing square. So this is cos raised to the power 4 theta plus 2 times cos square theta sine square theta plus sine raised to the power 4 theta. This is exactly equals to cos square theta plus sine square theta, the whole thing square. Now what we want is something in place of cos raised to the power 4 theta plus sine raised to the power 4 theta. So we are going to make this the subject of this identity. Okay, so cos raised to the power 4 theta plus sine raised to the power 4 theta is exactly equals to cos square theta plus sine square theta, the whole thing is square, minus 2 times cos square theta times sine square theta. And since we know the basic identity since P1 that cos square theta plus sine square theta is equals to 1, therefore we can rearrange it in this form. Cos raised to the power 4 theta plus sine raised to the power 4 theta is exactly equals to 1 minus 2 times cos square theta times sine square theta. So far we have achieved this one over here. Now we are left with this thing. Okay, so we are just going to inspect this 2 times cos square theta times sine square theta. So in place of this, what we can write actually that 2 is a constant term multiplied by cos theta times sine theta is squared. This square is only with cos theta times sine theta, not with 2. Okay, so now we are just going to see what we are going to write in place of cos theta times sine theta, and keeping in the mind that you are supposed to have something in form of sine 2 theta. And since we know the identity from the formula sheet as well, that sine 2 theta is equals to 2 multiplied by sine theta multiplied by cos theta. So what I can say is that sine theta multiplied by cos theta, when it is made the subject of the identity, sine theta multiplied by cos theta would be exactly equals to sine 2 theta divided by 2. So sine theta multiplied by cos theta or cos theta multiplied by sine theta, same thing. So in place of cos theta multiplied by sine theta, I can exactly write sine 2 theta over 2. So this is now in the form like this. 2 is a constant term, and then sine 2 theta over 2 is whole squared. So 2 is a constant term, and this is sine square 2 theta divided by 4. So 2 divided by 4 is half. So this is exactly equals to 1 over 2 multiplied by sine square 2 theta. So here you go. Just one step is remaining. So far we have achieved this thing. So as we can see that in place of 2 times cos square theta times sine square theta, we can exactly write half multiplied by sine square 2 theta. Therefore, cos raised to the power 4 theta plus sine raised to the power 4 theta is exactly equals to 1 minus 1 minus, and in place of this 2 cos square theta sine square theta, we can write half sine square 2 theta. And therefore we have proved this identity, and this part A was worth 3 marks. Now we have the next part. Hence, solve the equation cos raised to the power 4 theta plus sine raised to the power 4 theta is equals to 5/9, and the interval is that theta is greater than 0 and less than 180 degrees. So in place of this expression, we can write what we have proved in part A. We can exactly write 1 minus half times sine square 2 theta. 1 minus half times sine square 2 theta is equals to 5/9. We are going to solve this equation. Now let's just make the situation easier for ourselves. Let's take a substitution. Let's say x is equals to 2 theta. Okay, so your equation is like this: 1 minus half times sine square x is equals to 5/9. Now, first of all, we are going to find the solutions of x. Since x is equals to 2 theta, so all of those solutions will be of 2 theta. And as we know that the interval for theta is 0 till 180 degree, both are excluded. Okay, so the interval for 2 theta would be just multiply by 2 on both sides, 0 till 360. Therefore, we can say that x is greater than 0, less than 360 degrees. So first of all, what we are going to do is find the solutions in terms of x, all the solutions which could be in terms of x. So first of all, 1 minus 5/9 is equals to half times sine square x. So 1 minus 5/9 is how much? This is 4/9. So 4/9 is equals to 1/2 multiply by sine square x. So first make sine square x the subject of the equation. So 2 multiplied by 4 and then divide by 9. So sine square x is equals to 8/9. So sine x is equals to plus minus under root of 8/9. So when you are finding the basic angle, you always have to ignore the negative sign. So in order to find the basic angle alpha, since the basic angle alpha is always acute, it always lies between 0 and 90 degrees. So alpha is equals to sine inverse under root of 8/9. Okay, so our requirement is in degree mode. Convert your calculator in degree mode. So sine inverse under root of 8/9. The value of alpha is 70.53. Correct to 2 decimal places. Always take alpha correct to, always take the basic angle correct to 2 decimal places. 70.53 degrees. So first of all, we are considering a positive value of sine x. We are going to solve these two equations, right? Sine x is equals to under root of 8/9, and then we are going to solve sine x is equals to minus times under root of 8/9. So first I'm considering the positive values of sine x only. And what you are going to do is make the diagram for it, the diagram of the unit circle, not this, not the exactly circle, but you have to plot the slant lines in the respective quadrants, because if you don't make this diagram, you won't be able to solve any trigonometric equation. Okay, because you need to consider all the values which are coming in your interval. So always recommended to make this diagram. So first of all, I'm considering the positive value of sine x, and since I know the fact that sine x is positive in the first quadrant and the second quadrant, so in the first quadrant and second quadrant we are going to make the slant lines. This basic angle alpha always lies between the slant line and the horizontal axis, always between the slant line and the horizontal axis. So 70.53 over here and 70.53 over here. But also keep the fact in mind that we are finding the solutions of x, and the interval for x is 0 till 360, because x is equals to 2 times theta. So first of all, we are going to find all the solutions of x in the interval 0 till 360. So one possible solution for x is 70.53. X is equals to 70.53. Other solution for x is 180 minus 70.53. So 180 minus 70.53 would be equals to 109.47. And then we are considering the negative value of sine x, and since sine x is positive in the first quadrant and the second quadrant, this means that sine x is negative in the third quadrant and fourth quadrant. So in the third quadrant and fourth quadrant, we are going to make the slant lines, and this basic angle alpha always lies between the slant line and the horizontal axis. So 70.53 over here and 70.53 over here. So one possible solution will be 180 plus 70.53, 180 plus 70.53. This is supposed to be 250.53, 250.53, and the fourth solution of x would be 360 minus 70.53, 360 minus 70.53. This is 289.47. These four solutions are of x, which means that these all four solutions are of 2 theta, because x is equals to 2 theta. So in place of x, I'm going to write 2 theta. These four solutions are of 2 theta. So in order to find the solutions of theta, divide all these four values by 2, and final answer in degrees must be given correct to one decimal place. So 70.53 divided by 2, this is supposed to be 35.3, correct to one decimal place. Then 109.47 divided by 2, this is supposed to be 54.7 degrees. Then 250.53 divided by 2, this is supposed to be 125.3, correct to one decimal place. And the final answer would be 289.47 divided by 2, correct to one decimal place. This is 144.7 degrees. So these are your all solutions in the interval 0 till 180 for theta. And this part was what? This part was worth 4 marks. This was question number 8.